What's up everyone, welcome to the 9th tutorial in our Python language basics. Here we're going to deep dive into lists. We'll take a look at some examples of lists in action in real Python code. We'll start out by creating a list or two. Then we'll talk about how to access or modify individual list elements or the list as a whole. And then we'll finish up with some common list operations. Now realistically, lists have a ton of operations or functions we can perform on them, so we'll just cover some of the more commonly used ones, and then I'll leave you guys to explore the rest if you really want. So let's head on over to the code now. And this is where we left off last time with our logical and conditional operators. So let's go ahead and start a new cell. Just going to zoom in there for you guys, and we'll go ahead and jump right in. Okay, so let's consider a basic example, again related to game development, of having an inventory of items. Realistically, we can have a list of any type we want. It can be strings, ints, booleans, floats. It can be custom objects. We could create a separate item object and have a list of items, but we're going to keep things really simple. We'll just have a list of strings. We're only going to refer to items by their name. Okay, again, Python has dynamic list types, so we can have strings and booleans and doubles, or rather, and floats in there if we want, but we'll just keep it as just strings for now. Now, we'll set up a list in a similar way to when we set up a basic variable. We'll have the name equals and then the value. But because we have multiple values, we have to specify them between these square brackets here. We can actually start out with an empty list if we want and then add items to it, but we know exactly what's going to be in this list, so let's just add some items. So I'm just going to add some arbitrary inventory items that we might have. Maybe we have some bread, maybe we have some boots, something like this. Okay, so just put as many items in there as you want. Be sure to separate them with commas. So these are considered individual elements of the list. This is index 0, index 1, and index 2 because indexing is 0 based, much like most other languages. Now, some languages, such as C++, I'm thinking of in particular, will require you to have a specific length of a list. Okay? Not the case with Python, because lists are dynamic not only in type, but in size. We can add items to lists, we can remove items from lists. So it doesn't really make much sense to say we want a list of 5 items if you can add or remove items to and from it. Okay, so what if we want to change the entire list? We can absolutely do that. We can say inventory is now equal to something else. Maybe we want this and, whatever else we want in it. But we're not going to do that. We're going to talk about accessing the individual elements. So I just talked about indexing being 0 based. We can access items based on their inventory by selecting the list name. In square brackets beside it, put the index that we want. Let's say we want the first one. And then we can do whatever we want with this. So saying inventory of 0 now refers to this value. I can modify it. Okay, I can say it's equal to maybe a knife. Or I can just retrieve it and store it in a variable. So maybe I'll say something like sword is equal to inventory of 0. Maybe I want to change it, or maybe I'll change something else. So I'll say inventory of 1 is now equal to, instead of bread, we picked up some apples or something. Okay, so this is basically accessing sword and storing it here. This is modifying apples, or modifying bread and changing it to apples. So let's go ahead and print out the inventory after each of these operations, just so that we can see the changes take place. Okay, so we'll go ahead and run that cell. So this should print out all of the items in a list-like format. I think this, it's just being a bit slow. Okay, so we start out with sword, bread, and boots. Oh, actually, we're supposed to print out sword here because this isn't modifying the inventory itself. Okay, so we get sword, and then we've got sword, apples, and boots. Now, one thing to note here is that we are changing the original inventory. Okay, so this means if we're modifying this value here, it's going to change this original inventory rather than creating a new one and leaving this one untouched. Okay, behind the scenes it is technically kind of reassigning things and creating a new one, but for our sakes and purposes, it's as if this is the one being changed. Okay. Now, that won't necessarily be the case with all of the functions, as we're about to see. So let's actually go ahead and create a new cell so that we can kind of differentiate these two. So I think I stopped running this kernel. That's why these don't have the numbers beside them. And that's why we're kind of starting at 1 and 2 again. Okay, cool stuff. So created an inventory, or basically a list of strings. We've accessed an element. We've changed an element. Let's talk about some of the functions. So one of the very first things we might want to do is get the length of a list. Okay, that's actually pretty easy to do, and we don't even need it to necessarily be a list. We can actually just call upon the length operator. Okay, and then we just put the list name. So in this case, inventory. Okay, if we want to print out, we can do so. Let's go ahead and run that cell. You see we get 3. Makes sense. We are just retrieving the list of it. We can also retrieve stuff like the max and min. So we can print out the max of inventory. Inventory. Okay, or the minimum of inventory. Okay. So as you can see, the maximum is sword and the minimum is apple. So I know this seems weird because we're talking about strings and not numbers. But if you remember back to the operations section, the conditional operators, the string with the higher alphabetical value, in this case sword, is given a greater value, so that's why it's the maximum, whereas the minimum is the one with the lowest alphabetical value, which is A, so that's why it's considered to be the minimum there. Alright, so these are just some of the functions that we might want to perform on a specific list. However, these are not list specific, okay? We note how we're actually wrapping the list in the function parameters. There are some functions that are applied directly to a list specifically, and these are unique to lists. There are, I guess, equivalents of them in other collection types, but these ones aren't necessarily list specific. Okay, so another thing we might want to do with a list is be able to add items to it or insert items. We might want to be able to delete items from a list. Okay, and we might want to kind of clear the list out completely. So those are kind of 3 or 4 of the more common operations I find myself performing on lists. So to add an item to an inventory, or I guess to a list in general, you can use the append function. So let's say we want to add something onto the end of this. We can simply, I guess we'll just do that first. We'll say the inventory. Okay, and we want to append something to it. So now notice how we're not wrapping the inventory in these brackets. We're actually calling inventory dot and then the function. Okay, and then we'll just put in something else. So we got, let's see, sword, apples, boots. Maybe we have like a hat or something. Okay, so that will basically add a hat to the end of the list or to the end of our inventory. So we can go ahead and print that out. And we should have hat on the end. Okay, makes sense. Also note that at this point in time, the length of the inventory is 3. That does make sense. We haven't added anything to it yet, but as soon as we add something, it then becomes 4. Okay, so what if we want to insert something? So appending just adds something to the very end, just like we would append one string to another. Inserting allows us to insert at a specific index. Okay, so if I want to insert at the very beginning, for example, I could say insert index 0 and then the element that I want to insert. So this takes in 2 parameters, the index and then whatever we want to put in there. So let's say I do want to add a knife to it, okay, and then I want to go ahead and print my inventory after that change. I could absolutely do that. Okay, you can see knife is inserted at index 0. Note how there is something at index 0 already. This goes before that index. So if I inserted at index 1, it would be here before apples. Index 2 would be right here. Okay, cool. So that's adding and inserting. What about removing items? Now, there's actually 2 ways I can do this. I can remove something from the end using a pop function. Okay, or I can remove something at a specific index, or I can remove a specific item. Okay, so there's a few ways I can do it. Let's say I want to remove the very last item. That's easy to do. Just do inventory.pop, like so. If I want to print my inventory out, you should see that we'll have removed the last item. Let's see. So we've got knife, sword, apples, boots. Okay, so this is actually... let's see what's going on here. So it has removed the last element. The problem here is that the cells are kind of maintaining their state. So you know what? I'm going to reset things back to this. Okay, just so that when we go to rerun this cell, we are kind of resetting inventory every time. Okay, so that makes a bit more sense here. So what was going on before was that these cells do maintain their state. So every time the cell was running, it was rerunning these operations, but it was storing them back into inventory. So inventory was changed the first time, then the second time it kind of just built on that, and so on and so forth. Okay. But here you can see we start out sword, bread, boots, and hat because we appended hat. We inserted a knife, okay? But then the very final one was just popping the last item, so that was popping the hat. Okay, so that's to remove an element from the end. If we want a specific element removed, we could use the remove function. So we'll do inventory.remove like so, and let's say I want to remove the sword from there, okay? For whatever reason, we don't want the sword anymore. Okay, and then I'll go ahead and print inventory again. Okay, so you can see that sword is removed. So this is not taking in the index, this is taking a specific item to remove, okay? Finally, the last thing we might want to do is clear out the list completely. So if I want to do that, I can do inventory.clear like this, and it will kind of remove everything. Okay. Alternatively, I could just say inventory equals an empty list like this. This is probably the more kind of official way, the better way of doing things, but this also works. Okay. So that is some of the common list functions and a general intro into lists in general. We covered how to create lists. We only use strings, although again you can use any type you want. We talked about how to access an item, how to change an entire list, and how to change a single item. We talked about how to get a couple of the common properties of these lists. Again, there are lots more functions that we can use and lots more operations that will allow us to either retrieve or modify, or retrieve values or modify the list in some way. So I'd urge you to explore those. Once you're super comfortable with lists, we can move on to the next section. Okay, so thanks for watching. We'll see you guys in the next one.